Hey there, welcome back. Today's video is about the difference of two squares method. This is one of my favorites. On y va. So in this lesson, we're going to learn how and when to use the difference of two squares, otherwise known as the dots method. Make sure that you know how to factor using the GCF, very important, and also rewrite monomials as squares. In other words, if you can't comfortably rewrite 16x to the 6th as 4x cubed squared, you got to go back and review before starting this lesson. The difference of squares method is used to factor binomial expressions whose terms are squares. So you'll probably remember that a square is the result of a number being multiplied by itself 2 times. We have one basic formula. A squared minus b squared equals a plus b times a minus b. And as I've always said, words matter, math vocabulary matters. The difference of two squares, it can be written as the product of a sum and a difference. Sorry, it's my cheesy sense of humor. So, when can I factor using this method? We have a couple of requirements. We have 3. So, number 1, it has to be a binomial, so you need 2 terms. Number 2, it has to be a difference, so subtraction only. If you see a plus sign, can't do it. And finally, it must be 2 squares. Let's jump on in and try an example. All right, we want to factor z squared minus 25. First, I'll check for a GCF. I don't see one, so I'm going to double check my requirements. It's a binomial because it has 2 terms. It's a difference because of the subtraction sign. And finally, we have 2 squares. So we can get started. Let's rewrite both as perfect squares and then apply our dots formula. I like to leave placeholders in and then drop the numbers in. And we're done. Now that you know the process, for any of the rest of the examples, feel free to pause the video and try it on your own before reviewing the answers. Guess what? We have a GCF in this one. We have a GCF of S. I'm going to pull that out first, and we're only interested in the part inside the parentheses, so we're going to keep the S outside. Checking the requirements, this is a binomial, it is a difference, and it has 2 squares. So I can rewrite both numbers inside the parentheses. Okay, so 4 becomes 2 squared, t becomes t squared, and I can apply my dots formula. I keep my s outside, and I move my numbers. Then I double check, is everything fully factored? It is, so I can box my answer and go on. Let's try another one that looks a little complicated, but it's more straightforward than it seems. I'm checking for a GCF, and I don't have one. I'm going to double check my requirements because this one looks weird. I have 2 terms, u squared and u minus 5 squared, so this is a binomial. This is a difference, and both terms are perfect squares, so this actually is a difference of 2 squares problem. So I'll just rewrite, already done for me. Going to go ahead and throw my formula out there so I have space, and then I'm just going to move my terms. Now, usually I would need to check to see if it's fully factored, which it is, but if you can't tell, we can simplify further within the parentheses. U plus u minus 5 becomes 2u minus 5, and u minus the quantity u minus 5 becomes 5. I'll put that 5 out in front because we like to usually show our coefficient first. Okay, for this one, you can probably see that there's a GCF of 2a. So I'm going to go ahead and take that out. Okay, inside the parentheses, this is a binomial, it's a difference, and it has 2 squares. So we can rewrite both terms. That leaves a squared squared minus 9 squared. And we can use the dots formula. Plugging in. Okay, and our last step is to check to make sure it's fully factored. Is it? It's not. A squared minus 9 can actually be factored again because it's a squared minus 3 squared. So we keep everything else the same, and then we factor using dots again. Now we're ready to box our answer and move on to our final example. Okay, our factoring tree is growing slowly, but it's growing. Dots is our first method for factoring 2-term polynomials, otherwise known as binomials. We just need to be able to rewrite both terms as squares, and the rest is easy. Always make sure to check for a GCF at the beginning and that the binomial is fully factored at the end. Our next video is perfect square trinomials, which is going to take us into 3-term territory. I'll see you next time.